The next method in chemical behaviors of alcohols is how do they go for oxidation reaction. As you know, dear students, oxidation is nothing but addition of oxygen or removal of hydrogen. In oxidation, there is a presence of oxidizing agent who will do the process of oxidation very easily. So here we go for acidified sodium dichromate Na2Cr2O7. This will do the job of converting an alcohol into aldehyde or ketone, finally into acid. Let us see one by one the examples. Let us go with the primary alcohol, that is the CH3CH2 basis ethyl alcohol. It is coming under primary, and that on treatment with an oxidizing agent, acidified sodium dichromate, you can have a gas of removal of hydrogen first, one hydrogen from oxygen and one hydrogen from a carbon. So you can have a guess easily the product, and this will be the basic, will be repeated for dihydric and trihydric also, CH3 group, CHO. So acetaldehyde, it's an aldehyde, IUPAC name is 2 carbon atoms are there, ethanol will be the product. Further I am adding one more oxidation, the oxidation continues and you are getting COOH, that is the formation of acetic acid, or 1 and 2, ethane acid, so ethanoic acid. This is with the primary alcohol. What happens with the secondary alcohol? Secondary alcohol has this way, and the CH3. And first step, as usual, it goes for oxidation in the presence of sodium dichromate acidified. 2 hydrogens are being removed. You will get a double bond formed newly. CH3, CH3. This is acetone, propanone. Further, this goes for oxidation, and thereby an acetic acid is one of the product, and another product will be formic acid. So ethanoic acid and methanoic acid. So this is how the oxidation reaction will go on. Now our requestion is we need to stop the reaction with the aldehyde or ketone. We don't want the final conversion of acid formation. And if you closely see, the ethanol molecule has 2 carbon atom, acetaldehyde 2 carbon atom, acetic acid 2 carbon atom. If it is a primary alcohol, the same number of carbon atoms will be retained in the final product also, oxidized product. But if you go for secondary alcohol, in the reactant there are 3 carbons, in acetone also there are 3 carbon, but in the product there are 2 carbon or 1 carbon. So this may be asked in problems too. Less number of carbon atoms in a secondary alcohol. So somebody is asking, we don't want the final converted product of acid, we want to stop the reaction in this stage itself. So for that we have to go for PCC, pyridinium chlorochromate is taken as an oxidizing agent. He will do the job of converting primary secondary into only aldehyde and ketone, not as acid. Example, I go for CH3, CH2, CH2OH. This is 1 propanol. It's a primary alcohol. I go with the PCC, pyridinium chlorochromate. That oxidizing agent will remove the hydrogen, 1 from oxygen, 1 from carbon. The resulting product will be an aldehyde, that is CH3, CH2, CHO. This is propanol. It's an aldehyde. So further acid conversion will not take place. So depending upon the reaction requirement of the product, we can go for different types of oxidizing agent. Similarly, we can go for SWERN oxidation. This can be a 2-mark question. SWERN oxidation, dimethyl sulfoxide is important, and oxalyl chloride is also supplied, and they will also supply triethylamine. These 3 things will be supplied to a secondary alcohol, for example CH3, CHOH and CH3. This is 2-propanol. Dimethyl sulfoxide is having the formula CH3, S double bond O and CH3. And oxalyl chloride is nothing but Cl, C double bond O, C double bond O, Cl. Oxalic acid, by removal of 2 OH group, 2 chlorines are being added. And these things will react with triethylamine. You can see the product formation here. The 2 of the hydrogens will be removed, that we called as a oxidation process. These 2 hydrogens will join with these 2 chlorine to give 2 molecules of HCl. And this will come out as a CO, carbon monoxide. This oxygen and this CO will come out as a CO2, carbon dioxide. After all these removal, you can see 2 methyl groups and 1 sulfur, CH3 twice and S, and here you can see CH3, C double bond O, CH3 is the final product. So that is nothing but propanone, or a common name acetone. So this way of treating with the dimethyl sulfoxide and oxalyl chloride and triethylamine, you carry out the oxidation process that's having a special name called as a SWERN oxidation. We were talking about chemically what is happening into different alcohols, and we should understand what is happening inside our body. Biological oxidation is the next one. That means animals, they take food. All that carbohydrates they take in the form of food, they go inside the body and they go for the process called as a fermentation. So the final product of fermentation is ethyl alcohol. That alcohol may not be good for the body, and we have to detoxify. So liver is doing the job of detoxification of this alcohol and oxidizing that alcohol into acetaldehyde. So that is done by way NAD, nicotinamide adenine dinucleotide. This is doing the job. So we take ethyl alcohol that is being produced today in our body, and there is an enzyme ADH, alcohol dehydrogenase. This enzyme will do the job of the oxidation process easily possible. It is acting like a catalyst. So thereby we remove these 2 hydrogen and the product will be CH3CHO. This is acetaldehyde. In IUPAC name they talk about ethanol. You will get NADH and H plus will be. So this is every day it's happening in our body. That is oxidation of ethyl alcohol into acetaldehyde. Next one we have to talk about catalytic dehydrogenation. Whenever we talk about catalytic dehydrogenation, we require the presence of a catalyst like copper. That copper, heated copper at 573 Kelvin. How are these three alcohols go for dehydrogenation? Dehydrogenation means, it's very clear, I told you the other day, removal of a hydrogen only. So let us take one by one alcohol. As usual, we go with the simplest alcohol, ethyl alcohol. Two hydrogens are being removed and the product will be CH3CHO, acetaldehyde. So primary alcohol gets converted into aldehyde. Primary alcohol gets converted into aldehyde. This is one of the product. And suppose you go for a secondary alcohol, CH3, CHOH and the CH3. This is isopropyl alcohol. That will get converted into CH3, C double bond O, CH3. What is happening? Two hydrogens are being removed. Dehydrogenation. Here, the secondary alcohol gets converted into ketone. So this way you compare and learn, the learning becomes interesting and easy. If you go for a tertiary alcohol, tertiary butyl alcohol I have taken now, that doesn't have any of the hydrogen to be removed. One hydrogen can be removed from oxygen, another hydrogen cannot be removed. So instead it will go for elimination of hydrogen from this position. Thereby this goes with electron as OH minus. Hydrogen will go without electron as H plus. And both of them join to form water. So it is not dehydrogenation. For tertiary alone, it is dehydration. That means below the arrow mark, it is a molecule of water being removed. And as usual, only the bond get shifted here. The product will be CH3, C and the CH3 double bond CH2. We told the name also, it is an alkene, and that alkene is having a name isobutylene, or we can say 2-methyl pro 1-ene, 2-methyl propane. So this is the difference. Primary gives aldehyde, secondary gives ketone, and tertiary gives an alkene, a double bonded compound. So this is catalytic dehydrogenation. An interesting reaction called as esterification reaction. And most often when we prepare this particular chemical, and all other department people will come and look at us with a proud sense. The reason is a whole lab, when we prepare this, will give a very, very pleasant fruity odor. Sometimes when we go for esters being prepared, we can get the fragrance of jasmine or other flowers. So this is very interesting and pleasant test in chemistry. That is esterification. What are we going? We are going to prepare esters only. And as you know, esters are the compound who will have a C double bond O group. And how to prepare? Always an alcohol, maybe a primary alcohol, reacts with the carboxylic acid like acetic acid. And this happens in the presence of a catalytic amount of concentrated sulfuric acid. And there will be loss of a molecule of water, and after the loss of molecule of water you will get CH3, CH2, CO, C double bond O, and CH3. If you closely see the molecule at the middle, we got an ester. So that is why this reaction is called as esterification reaction. See the name of the product. This side is ethyl group and this side is acetate. So the name of the ester is ethyl acetate or ethyl ethanolate. Two carbon atoms are there. So the name ends with the 8. So this is having the fruity odor. So this the name of the reaction is esterification.
A small quantity of organic compound in a test tube. To this, add a small quantity of glacial acetic acid using a dropper. Using another dropper, add a few drops of concentrated sulfuric acid to the test tube. Warm the mixture in a water bath for few minutes. Now, pour the mixture into about 20 milliliters of cold water taken in a beaker and smell it by wafting. Alcohol reacts with carboxylic acid in the presence of concentrated sulfuric acid to form a fruity smelling compound called esters.
Now let us learn the chemical behaviors of glycol. Glycol is a compound which is having two OH groups. And what is the speciality? Both the OH group are primary alcoholic in nature, CH2OH in nature. So all the behaviors of primary alcohol like ethyl alcohol will be repeated twice here. Like treatment with the sodium, there you will get a sodium methanate. Here also you will get a monosodium glycolate and disodium glycolate like that. And converting OH group into Cl by PCl3 or PCl5, thionyl chloride, all those reactions will take place. Let us take the example of treatment with the phosphorus triiodide, and this OH group will be removed. In the place iodine will be added. You will get CH2I and CH2I. This is 1,2 diiodopentane. As you know, two iodines in the neighboring position is not stable always. They will come out as I2, and this bond gets shifted here. You will get the formation of CH2 double bond CH2. It is nothing but called as the ethene. And some places I'll write the molecular formula. You can also do that in your book, textbook. And glycol with the molecular formula C2H6O2, two oxygens on treatment with the phosphorus triiodide get converted finally into ethene with the molecular formula C2H4. So if you write the molecular formula and you just practice this equation, and that will be very useful for you. And next one, the glycol molecule will go for nitration reaction. Nitration means addition of NO2 group. So what is the mixture used? It is a concentrated nitric acid and concentrated sulfuric acid. This is a nitrating mixture usually go for nitration, addition of NO2 plus nitronium ion. The same way we go for glycol also, CH2OH, single bond CH2OH. Since you are adding nitric acid, I can split the nitric acid this way, HO, NO2, and here also HO, NO2, this is HNO3. Sulfuric acid will remove the water in between. So after the loss of molecule of water, two nitro groups gets added with the glycol, you'll get CH2ONO2 and here CH2ONO2. So this is called as 1,2 dinitroxy, two nitroxy groups. 1,2 dinitroxyethane is the product. And similarly this can be called as glycol dinitrate, and these are all explosive. The next one we have to talk about what is the formation of epoxy reaction heating at 773 Kelvin. So ethylene glycol, as you know, it is having the formula CH2OH, ethylene glycol. When you are heating a molecule of water will get removed. So thereby you will get CH2 single bond CH2 and oxygen is being connected. So 1,2 epoxyethene is the name of the compound. Ethylene epoxide is otherwise known as 1,2 epoxyethene. So next dehydration method. is intramolecular. This is another intramolecular dehydration. For that, we need the presence of anhydrous zinc chloride or concentrated sulfuric acid. What is the duty of them? They have to remove the water. Imagine it is ethylene glycol, and the molecule of water is being removed this way. This double bond shift here, making it a double bond. The equation becomes this way: CH2 double bond CH single bond OH. And this hydrogen goes here to join with CH2 to form CH3, and the bond shifts here. That carbon oxygen double bond will be formed, and the final product will be CH3 single bond CHO. This is nothing but acetaldehyde. The molecular formula for this compound is C2H6O2, and the molecular formula for this is C2H4O. So this could be asked in problem 2 as giving the clue as anhydrous zinc chloride. Intermolecular dehydration, that means the removal of water H2O. And who will do the job? Will concentrated sulfuric acid will come for our help. I am going to take two molecules of glycol. I am going to stretch the molecule a little differently. This way, this is ethylene glycol first molecule, this is ethylene glycol second molecule. And if you closely see, the right hand side, one of the water will be removed, and oxygen link will get connected here. And left hand side also, one of the molecule of water will be removed, the oxygen will get connected. And the resulting compound will carry CH2 single bond CH2, this link, and another ethylene glycol CH2 single bond CH2. Both the ends it will get connected with one oxygen. So this molecule is otherwise known as dioxin or 1,4 dioxin is the name of the molecule. So this can also be asked in a problem 2. So this is intermolecular, between the molecules, the water molecule got removed. The next, let us learn the oxidation reactions of glycol. As you know, oxidation is nothing but removal of hydrogen or addition of oxygen. The same thing only, like we learned from primary alcohol, similar process, because primary alcohols on oxidation will get converted into aldehyde. That again on oxidation will get converted into acid. Same thing only, but 2 times it will happen. So if you go for a molecule like ethylene glycol, it has 2 primary alcoholic groups, CH2OH, CH2OH. When it goes for oxidation, in the first step what happens, one of the carbon alone, let us take a primary alcoholic group, one hydrogen from here, one hydrogen from here is being removed. You will get CHO, CH2OH. This is ethylene glycol. This is glycolic aldehyde. Same thing, only with the aldehyde. Let us proceed again by adding one more oxygen here. It gets converted into COOH, CH2OH. This is glycolic aldehyde, but this is acid. So name comes as a glycolic acid. Again goes for oxidation. The second carbon will get involved, and now we get COOH single bond CHO. This is called as glyoxylic acid. Now again add oxygen, the final product will be COOH single bond COOH. This is oxalic acid. So the final product is oxalic acid. And there is one more possibility is also possible. This hydrogen and this hydrogen, if you remove, you will get CHO, single bond CHO. This is called as glyoxyl. and this again on oxidation will give you glyoxylic acid. So the step will be continuously proceeding for oxalic acid. So if you go with only first carbon, this will be the row. First carbon, second carbon involves from here, this will be the possibility. And we have to understand the IUPAC names also here. Ethane 1,2 diol. Here there is a presence of aldehyde group and alcohol. So first carbon, second carbon, 2-hydroxy ethanol, Al for aldehyde. Here acid group and alcohol. Alcohol is at second position. So 2-hydroxy ethanoic acid. And this is a formyl group. In IUPAC, aldehyde can be called as formyl. So this is a formyl methanoic acid. Methanoic means one carbon. Methanoic acid. This is the ethane dioic acid. Or if you go for periodic acid, HiO4, periodic acid, then the product will be entirely different. See, we are going for same glycol, ethylene glycol. On treatment with the periodic acid, I am writing the formula this way: iodine, double bond O, this side OH group, and this side double bond O. And you closely watch, there will be water molecule removed. And the resulting compound coming out will be HiO3, one of the product. And then there will be shifting of bonds whereby therein the carbon-carbon bond will break. And here we get one CH2O, here one CH2O. It is nothing but two molecules of formaldehyde, HC double bond O, H. By the cleavage of a carbon-carbon single bond, you will get two formaldehyde molecules formed. This is how this ethylene glycol reacts with the periodic acid. We learned the chemical behaviors of glycol. It is our turn to learn about glycerol. And glycerol's chemical properties are quite interesting because this glycerol molecule has 3 OH groups. It is a trihydric alcohol. That too, it is having a combination of 2 primary alcoholic groups and 1 secondary alcoholic groups. So from glycol, it may differ in a little reaction. For example, glycerol, when it goes for a nitration process, nitration we learned just now on treatment with the concentrated nitric acid and concentrated sulfuric acid. It will generate NO2 plus ion. Let us see how it reacts. I am writing the nitric acid formula this way: HONO2 in all the 3 places. HONO2. So the loss of water and taken away by sulfuric acid, and at the end you will get formation of CH2ONO2, CHONO2 and CH2ONO2. This is called as glyceryl trinitrate or nitroglycerin, or this is can be used in the preparation of a very, very dangerous explosive called as dynamite. And this is nitroglycerin. And glyceryl trinitrate, GTN also we can call. This is one of the important reactions. How will we prepare an explosive, or they'll ask how will you prepare dynamite from glycerol. And the next reaction, it goes for dehydration. Dehydration we learned, and removal of water. It goes for intramolecular dehydration within the molecule. And the dehydrating agents can be KH sulfuric acid H2SO4. So this goes for dehydration. I'll write the molecule CH2OH, single bond CHOH, here CH2OH. So the molecule of water gets removed, and when a molecule of water gets removed, you will get the formation of a double bond. So you will get CH2 double bond CH, single bond CHO. So there is a formation of an aldehyde, that's true, but it is having a double bond also. So it is an allyl aldehyde, otherwise known as acrolein. Very important problem question. Mark it for problem, and this they will give it as a problem clue. The dehydrating agent. And here the molecular formula for glycerol, you can write C3H8O3, and here you see C3 in number, H4 and O. IUPAC name is, from here you have to start 1, 2, 3, you have to say prop, double bonded, second position, prop 2-ene, and ale, that is 1 ale, propene. So 2-propanol or propene 2-enal is otherwise known as acrylic aldehyde, otherwise known as acrolein. And for 1 mark is oxidation reactions of glycerol. Similar manner to glycol only, but we have to check this secondary alcoholic group also. So with that, the product also will differ. As you know, it carries 2 primary alcoholic groups. Primary alcohols will on oxidation gives aldehyde, and 1 secondary alcoholic group. Secondary alcohol on oxidation gives ketone. So depending upon the oxidizing agent, the product will also differ. How? First, let me try with the first carbon alone. Primary alcohol gets converted into aldehyde. And earlier this molecule was glycerol, now with aldehyde. So this is called as a glyceraldehyde. CHO. And this molecule is having OH group, primary alcoholic group. And as this was done, the other one can also be done. Before that, let us finish this aldehyde group converting into acid group, COH, CHOH, and CH2OH. So this is glyceraldehyde with acid, so it is called as a glyceric acid. Glyceraldehyde got converted into an acid. And this again will get converted into aldehyde and get converted into acid. So this primary alcohol on oxidation will give you this side also an acid. Both are acids. The name of this acid is tartronic acid. Tartronic acid. Till now we were talking about only primary alcoholic group converted into acid. Now we are going to discuss about what happens with the secondary alcoholic group. Now secondary alcohol group, again on oxidation, you will look at the product here, CH2OH, C double bond O. This got converted into ketone, and here it is CH2OH. Both the sides, the primary alcoholic group are remaining as such, but that CHOH alone got converted into a ketone. So this is dihydroxy group. Similar to acetone structure is available. So this is dihydroxy acetone is the name of the compound. And this molecule again on oxidation, the secondary alcohol will get converted COOH, C double bond O, and COOH. This is having a special name called as mesoxalic acid. Mesoxalic acid. And that again on further oxidation, the carbon dioxide group will be removed and we will get the COOH, single bond COOH. This is called as oxalic acid. And imagine this goes for removal of hydrogen, and on oxidation we get converted into mesoxalic acid also. So anyway we can proceed. So we can go with the primary alcohol first and then secondary alcohol this way also possible. So if you want to stop the reaction at a particular level, also possible. How? If you go for only dilute nitric acid, dilute HNO3 will give you a combination of glyceric acid and tartanic acid. These two will be the product with the dilute nitric acid. You go for concentrated nitric acid. These can be asked in objective too. If you go for concentrated nitric acid, it will give only glyceric acid. So I want glyceric acid alone means you have to go for concentrated nitric acid as an oxidizing agent. Suppose you want the combination of these two, that is glyceraldehyde and dihydroxyacetone, together they call them as glycerols, can be asked in 2 mark also, important. When this will happen in the presence of bromine water, or you can go for sodium hypochromite, or Fenton's reagent, another 1 mark question, Fenton's. Fenton's reagent is ferrous sulfate and hydrogen peroxide. So if you supply these people as oxidizing agent, then you will get a combination of the two called as glycerols. Otherwise, if you go for bismuth nitrate, then the glycerol will get directly converted into mesoxalic acid with the bismuth nitrate. Or you go for KMnO4, it will get converted into oxalic acid. If you want formic acid, you have to go for LTA, lead tetraacetate, or you have to go for periodic acid. So your product can be decided by your application of the proper oxidizing agent. That's why glycerol's oxidation reactions are very important in a public point of view. So learn it with 2 or 3 times of writing with a particular oxidizing agent, then it becomes interesting and very easy for you to learn and write in your exam. So let us now learn the uses of alcohols. So learning chemical properties and physical behaviors along with the uses, if you learn, that will support you for problems too. And also another thing, we can understand in which are the areas we find a lot of uses of alcohols. Otherwise it becomes a simple learning only. So we have to link with our life. So uses we can classify according to the particular alcohol we learned. The one alcohol is methanol. See, methanol is nothing but methyl alcohol, has the formula CH3OH. It is a monohydric alcohol. I told you it is a deadly poisonous substance. And also it is a very good substance in the field of paints, varnishes, and also shallots. And when preparing many of the organic compounds, this is used as a wonderful solvent, because it has the capacity to dissolve the organic compound available in the plant and bring it to us. And after some time, recrystallization is possible because this is volatile and easily evaporable. And from form methyl alcohol methanol, preparation of formaldehyde is possible. From that, formic acid is possible. So all these are the uses of methyl alcohol or methanol. The next member we have to talk about is ethanol. So ethanol is a CH3CH2OH. It is again a primary alcohol, and this ethyl alcohol is having a wide variety of uses, starting from beverages, alcoholic drinks, I mean to say, from the use of sanitizers. We are talking about alcohols as a very good solvent and material used for the extraction, and they are thinking of power alcohol, or they call as alcohols. They can be mixed with the petrol used as a fuel for the automobiles. And nowadays they are thinking of converting sugarcane into ethyl alcohol and using it as power alcohol, or from corn. India is a major producer of that. That can be converted into ethyl alcohol after fermentation process. Apart from that, so many other compounds are possible, like acetaldehyde preparation, or we learned chemical properties, oxidation, acetic acid. It can be used for preparation of chloroform, CHCl3, an anesthetic. In many of the organic compound preparation synthesis, everything ethyl alcohol is finding its own use, and also in the industry of paint. And what are the uses of glycol? Glycol, as we know, it is CH2OH, single bond CH2OH. It's a dihydric alcohol. Ethylene glycol is a wonderful compound for the preparation of antifreeze in automobile radiators. Now, what is this? The automobile radiators, sometimes they may be placed in open air, or the vehicles will be placed in Western countries outside the home, in the garage and all, and the temperature in the night hours will be too cold. It may be minus degrees. So the water in the radiators at normal conditions may freeze out, and the radiator tubes will break, and without knowing that, morning you start the engine and go a long distance, and due to overheating the engine may cease. To avoid that, they will add ethylene glycol that will decrease the freezing point of water, so that the material inside, or the water inside the tube, will be in liquid state for longer. That is on antifreeze. And ethylene glycol's usage in the preparation of explosives, like glycol dinitrate we learned, and also it mixed with the TNG for the preparation of explosives. And next one we learned about glycerol. Glycerol again is widely used because it is also having the sweet tasting substances, so that behavior is also there. So glycerol is a trihydric alcohol, and it is used in the preparation of cosmetics, and the moisturizing cream we apply. When we go out, this has the capacity to absorb moisture, hygroscopic in nature. When we go out in a hot sun, and by applying these creams, it will absorb the moisture from the atmosphere and keep our skin always wet, so that the sunburns or tanning of our skin won't happen during the summer. And another thing is, it is added in the sweetener in syrups also. Otherwise, children may not take if the taste is bitter. And glycerol is added in a stamp pad, that is in the offices you can see, for sealing purpose they go for a pad, a stamp pad. So that even if you open and place it, and the usability will be good. The reason is, along with the ink, the dye, they will add glycerol, so it absorbs some moisture and keep the pad always wet, so that it can be multiple times used. And glycerol again used for preparation of dynamite, that is glyceryl trinitrate. and soap preparation, it is coming as a byproduct. And glycerol's chemical nature, it gives so many of the product like oxidation products we have seen depending upon the oxidizing agents. So different compounds can also be prepared out of glycerol. So these are the areas we have to concentrate for our problem clues. Whenever we learn and use, on the sides you underline the keyword and try to mention it can be used as a problem clue to identify the particular alcohol. And whenever you learn the formula, you have to write also the molecular formula so that your easy cracking of the problem questions in the public exam will happen. CPHA43. So this is the first half of the lesson where we are talking about aliphatic alcohols. They are monohydric, in monohydric primary, secondary, tertiary, and dihydric as glycol, and trihydric we learned about glycerol. So the learning organic chemistry, I believe it has come very close to you, but its main thing is minimum 2 to 3 times after understanding you have to write and practice the equations. Thank you.
Ethanol is used as a solvent for paints, markers, perfumes, and other products. It is used to prepare various organic compounds. It is used as a motor fuel and fuel additive. Many bacterial hand sanitizers contain ethanol. Alcoholic beverages contain ethanol. Ethanol is a central nervous system depressant. In low doses, it leads to fewer inhibitions and reduced concentration. Poor judgment and slow reflexes are also hallmarks of ethanol consumption. In moderate doses, ethanol can cause slurred speech, drowsiness, and damage to the liver and the gastrointestinal tract. In higher doses, ethanol can lead to vomiting, breathing difficulties, and unconsciousness, which can be fatal.